got the number one down? I'm going to explain it very quickly again. I know you probably have it. Yes? No, I don't. Can somebody lend him a pencil? Oh, I got a pen. Does that work? I figure you might have it down. This is problem number one. Problem number one. Does anybody care? Okay, I'm going to prove that vertical angles are equal. Hello? Over there, singer. Okay, so I'm going to show that angle 1. All I want you to show that angle 1 is equal congruent to angle 3. And I'm just saying what you're given is the simplest of all. Line 1 and line 2 intersect. That's it. Okay, now I did this in green. You see that arrow in green? That's angle 1 plus angle 2 equals 180. You see the blue line? Got number 2. Angle 3 plus angle 2 equals 180. You see that one? So the green angle is 1 plus 2, and the blue angle is 2 plus 3. And why? These two are the definition of straight angles. That's why I want to see it, your aim and your reason. That's about it, because from here on out, I'm going to subtract angle 2 from both sides, and I got angle 1 equals 180 minus 2. I'm going to subtract angle 2 from both sides, and I got angle 2 equals 180 minus 2. Okay. If angle 1 equals that, and that equals itself, and this equals that, then that is A. If A equals B, B equals C. Yeah.
For number 4, wouldn't it be
Yeah, good, thank you. Because I subtracted angle 2, I got angle 2 and angle 2. Great. Good observation. Okay, so if this is A, and this is B, this whole quantity, and this is B2, and that's C, then I can say 1 equals 2. Thank you. Okay, got it? Got it? Okay. Let's go to the second problem. I'm trying to finish by reading about this subject. I'm not covering again. But I think we can get it done in short order. Okay, number 2. This is prove alternate interior angles. Prove that alternate interior angles are equal. Okay. If you don't want to pay attention to your class. Okay. All right. So I'm going to tell you, as always, what's given. I'm going to say that L1, this means parallel to L2, that's the line. And I'm going to have L3 parallel to L4. Okay. And then I'm going to have, and not only is L3 and L4 parallel, they are perpendicular. Perpendicular means at a right angle. I draw this to mean perpendicular. But I'll call it so underneath it, so you know it means perpendicular. Okay, got it. So I'm saying you got 2 parallel lines, and you have another 2 parallel lines, and they meet. perpendicular angle. Okay. The only thing I have left now is L5 traverses, that means to intersect all lines. Hey, okay. Okay. L5 traverses all lines. Okay. All right. So here we go. This is going to be. Let's do the drawing. Hey, can we be quiet, please? What else can I say? Quiet. All right. Here we go. Here's line 1. Oh, let's do it like this. Okay. Line 1. Line 2. Okay. And then I'm going to have. Okay. Then I got line 3 and line 4. Okay. Okay. All right. Now I'm going to do L5. Okay. And I'm going to call this L5. Now, if you see that L5, you can see the L5 actually intersects all lines. Okay, and this is the definition of alternate pure angles. This angle is congruent to this angle. All you have to do is show angle 1 is equal to angle 2, and we're done. I want you to show this really. Any questions on what's given? We got 2 parallel lines. This parallel line means perpendicular to the other parallel line. Okay? So I'm saying the following then. Let's see how we can improve this. Okay, number 1. I'm going to say because L1 and L2 are parallel, that by definition they're always the same distance apart. So I'm going to say that this is congruent to this. And what else? Well, these are parallel lines. So the distance between them is equal. So this is congruent to this. And then simply, the last step, I thought my step, but I can say that this is equal to itself. Now the reason I'm saying that, that's the hypotenuse for both triangles. If I could take this one out like this and turn it, I could lay it right on top of the other triangle. Okay. So the first one is I'm just going to say exactly what I did. In order to label it, I'm going to call this vertex A, vertex B, vertex. Let's call this one C, and we'll call this one B. Okay, so I'm going to argue first that line segment AB. This means line segment. That line segment is going to be congruent to CD. You got it? Okay. And I'm going to also argue that AC is congruent to. Okay, now I'm going to give the reasons over here for my argument. This is, both of these are going to be the definition of parallel lines. This one's the definition, it means parallel lines. Okay, and finally, this looks kind of odd, but I'm going to state it, that BC is congruent to itself. Right? And the only reason I even bring it up is because both of them are sharing that. Okay, now I'm almost done because I'm just going to say that triangle ABC, right, is congruent to triangle PDC. That's a B. Triangle PDC. Okay, and so I'm arguing that these are congruent. Now, this is also, this is called the identity of itself. Okay, I'm arguing these are congruent. What reason do I use? Side, side, side. Yeah, I'm saying that this is congruent to that. This is congruent to that. This is congruent to itself. That means by side, side, side. Yeah. Identity. Yeah, that's not very clear. Identity. Let's put ID. Or identity. This is going to mean identity. Okay, now I have argued that these two triangles are congruent because of SSS. Okay, and so as a result of that, I want you to understand that if you have two exact copies of the triangle, you have the same angles are equal. If they're exact copies, then it's not. Now, what does angle 2 correspond to? Look at a 2-tick and a 3-tick. Look at here, a 2-tick and a 3-tick. So I'm arguing that through this, so that finally, the one is, I'm going to say angle 1 is equal to angle 2. That's the proof. That's all you had to show me was that the alternate interior angles are equal. Can you do that tomorrow? Okay. I'm expecting a lot. All right. Last one. Oh, everybody got it? You got it? Yeah. I probably have it by my memory now. Okay. Anybody else? Let's go right.
It's putting each eye down, right?
Okay. Tomorrow, they let me do it. I'm going to bring in my metal detector to show you how it's set up. When I go looking for gold. Okay. I'm not sure because I kind of like it done. Okay. So, any questions? All right. And the last problem. Number 3. So that the interior angle of a triangle equals 180 degrees. There he goes again. Now, Bender.
Hey, you'll be like in time. I'll get the very part. That's why you should get an apple.
Hey. All right. Okay, so I'm going to tell you what I'm going to give you what, and I'm going to give you what's given. Given. That's what I was looking given. Did you tell I have to given. Okay, we're going to have L1 parallel to L2. Okay, and then I will have L3 and L4. Each one of these lines will intersect parallel lines, L1 and L2. So I'm just saying these two are parallel, and these two lines will intersect those parallel lines. And they won't be parallel themselves. I'm not going to bother to write it, but let's go like here. Well, I'll just do it here. Let's say that that's L1. Let's say that this is L2. All I'm saying that L3 and L4 intersect it in this way. All right? And all I'm asking you to show is that, I'm just going to ask you to show that angle 1 plus angle 2 plus angle 3, what you're supposed to just show me is that angle 1 plus angle 2 plus angle 3. That's all I need to show because that's the interior of any triangle. How do I know any triangle? Because I can adjust this angle to any kind of triangle I want. Okay. I know. Okay, here we go. And now I'm going to simply label this one 4 and 5. Okay, and I'm going to draw a green arrow like this. I'm showing that it's equal to, no. So my first argument is that L1 is a straight angle. See how easy it is? So I have, I'm going to say angle 4, angle 2, plus angle 5 equals 180. And why? Because definition of straight angle. Okay. Okay, number 2. Okay, so I know that because we just proved, what did we just prove before? What was the last proof? No, I'm talking about problem number 2. What did we solve in problem number 2, anybody? Yeah, which means what? What kind of angles are they? Huh? Parallel angles. No. Look, I'm arguing that what we proved that alternate interior angles are equal. You got to connect problem number 2 with problem number 3. Because I'm going to call angle 4, I'm going to say that it's congruent, right? So I'm going to say that angle 4 is congruent to angle 1. Why? By number 2 that we just did, we proved that alternate interior angles are equal. Why? Because on problem number 2, I'm trying to have it tied together like a theme. Okay, so 4 is congruent to angle 1 because we just showed why on number 2. Okay, likewise, I'm going to show this. Okay, I'm going to show that this corresponds to this. Why? Why? Yeah.
That's Nathan. Good job.
Okay, so I'm going to argue that angle 3, right? Angle 3 is congruent to angle what? 3 is congruent to what? There you go. And I guess that's the same reason. Alternate definition. Well, what we showed earlier, alternate distance interior angles are equal. Okay, there we got it. Okay, now I'm going to argue this. I'm simply going to say here, I'm going to take this. I'm going to take. All right, I'm going to take this line. And I'm going to substitute I'm going to say if angle 4 is equal to 1, you see I'm going to replace the 4 with angle 1, right? I'm going to replace angle 4 with angle 1, and then I'm going to copy the angle 2. You see it here? It's copied from here. I just copied it. And I replaced 4 with 1. Right? And now I know I can replace 5 with 3. Why? Because they're equal. So I'm going to go 5 with 3, and we're pretty much done. Okay. So now I'm just going to add that angle 5. I will substitute with angle 3. Hey, what's your take? Okay. Now, I'm saying that, and this is still equal to 180 degrees. What is it we were meant to show? Simply that the interior angle is equal to 180. And what is the final argument as far as this idea of putting in there 4 for, right, 1 for 4, 3 for 5. That right there is by substitution. Okay, and there you have it. That's the last form of the test. Is there any questions? So to me, it's fundamental that you understand that 2 is being used to prove number 3 by alternate interior angles. Is there any questions about that? Okay, I'm going to go on to another topic. I'd like to talk about areas, both rectangles and circles. Now, if you got this, then yeah. Okay. Yeah. I'm trying to record it, so I'll put it in Google Classroom with success. Okay. Now, if I suppose that I want to measure, let's say from A to B. Okay, so if I want to measure from here to here, this is called a linear distance. This is called a linear distance, okay? Any of you that are even in going to landscaping or even architecture, you got to know the difference between a linear distance. So I'm just going to say, for the sake of example, that this is 3 meters. Now, what is a meter? Okay, in the metric system, the rest of the world, except this country, is costing us a lot of money, actually, because they have different measurements than ours, and there's a lot of mistakes being made. But this, basically, a large step is meter. A meter and a meter. So when you're in the military, if you're in the military, they tell you to go 500 clicks. Okay, a click is a meter, so but it's also a step. So these guys going through the jungle or whatever, they'll take 500 clicks. Then take a right and go 300 clicks. Okay, and 1,000 clicks. 1 kilometer. Yeah. What? It is not. A meter's bigger. Okay. Okay. They're not equivalent. But here's the thing that doesn't make sense in our system. For example, imagine that you have a dollar. To get to a dollar, you can have 5 cents, 10 cents, 25 cents. If you notice, they're pretty easy to get up to a dollar, right? So let's say 10 cents. How about if we change 10 cents to 12 pennies? That's basically our measurement. Why? Why? I don't know why. Why wouldn't they make it 10 inches? Because it's a lot easier. Then you could say 30 inches makes a yard, not 36. Does anyone know how many feet in a mile? That's metric. 1 mile is 5,280 feet. That's what I'm saying. Whereas with the clicks, that's why they use metric. They know that 1,000 steps is 1 kilometer. And let's talk about temperature. Temperature had to be a drunk German or something through a dart. Why anybody in their right mind would call freezing 32? Does anybody know what boiling is? What is it? No, the temperature at which water boils at sea level. Let me show you what I'm talking about. Why everybody thinks we're crazy by using our system. We have this thermometer, right? It's going from basically freezing. For some reason, he picked 32, which makes, again, like, why 12 inches in a foot? Okay, in case you don't know, boiling water is at 212. Now, you probably don't know because it doesn't make much sense. Okay, what do we do in metric? When we go in centigrade, we go like this. And what's freezing? And what's boiling? That's metric. Should be more reasonable.
And that makes more sense.
That's what I'm trying to say. People are really used to it, but it's strange from another country. See that why are you calling freezing 32? And why boiling is 112? Well, where did you come up with the numbers? It has no consistency. Yeah.
You know, in the computer world, they tell you Celsius over Fahrenheit.
They tell you what?
In the computer world about like overclocking the temperatures, they tell you Celsius over Fahrenheit.
But all scientists in all other countries use metric. We inherited this measuring system from England, and England doesn't use it. We're still using miles. At least in a kilometer, you know it's 1,000 long steps. Thick in the military. Okay? And everything's like that. It's really weird. It's be like, okay, I'm going to call 10 cents 13 cents. Now figure how many in a dollar. Okay, and I can't explain why it's so weird. Our money is in fact metric because 100 pennies make up a dollar. 10 dimes make up a dollar. But if you change it to our measurement, then you'd call a dime 13 cents and a quarter 27 cents. Anyway, I hope you begin to see the difference. And it's the same with the weight, with kilograms. Same with volume, with liters. 1,000 milliliters make up a liter. We got how many pints make up a gallon? I don't know. I don't really care to know. Okay, so anyway, this distance right here, I'd like you to know that any time it's a straight line, we're going to call that linear distance. Okay, and I'm going to call this 3, meters. So what that means is it takes 3 long steps. So when I have to write the units, because each one of these meters, if it's linear distance, you're going to say 3 meters, just once. This is what I don't like about high school. You have to like I used to. Okay, but the rest I love too. Now I'm going to talk about area. Suppose I have 3, and let's say I have 7. So I got 3 meters here, and I got 7 meters here. Okay. So now I'm asking you to find area, or it doesn't matter where I put it. Okay. Can somebody explain to me over there what's my area? You? Yeah. Okay, almost. He took the 3 times the 7. What he forgot is you have to multiply meters times meters. So anytime you see a squared, you're talking about area. So when you need to lay down carpet or whatever it is, you want to find out how much carpet, you're not going to go to wherever you buy the carpet and tell them you want 21 meters. They'll think it's linear. Understand? If they don't see that, then they're going to think it's linear. Yeah. Okay, now go like this. If I go, let's say, let me put a box here. Something like this. Okay, I got a box here, and I'll put another box here. Okay. Now I'm going to call this what? I'm going to call this 3 meters by 3 meters by not quite. You have 3 different axes. But another 3. So I have the area of this guy back here in flatland is in fact 9 meters squared. But with volume, this one's going to be 27 meters. Right. Now, if you have a motorcycle or car, you might see something like this. 3,200, let's say 3,200 cc. You ever seen that on a motorcycle, the cc? Has anybody seen the same cc on a? Okay, that is the piston displacement of the car, measured in cubic centimeters. Okay, so I'd like to know the difference between linear, between area, and between volume. Right? It looks to me like that's not over. Don't leave the class yet till the bell rings.